We've seen many different ways to train the model. So we explored in session 4 how to train the model using an out-of-the-box TensorFlow container. In session 5, we looked at how to train a model using Keras 3 with a JAX backend and a custom Docker container. And in session 6, we saw how we could train a model using a tuning step. So instead of training a single model, we can get multiple models. Now in session 7, we're going to talk about evaluation. And this is one of the most important topics in machine learning. You should not be putting models out there that are not working as you expect. So we want to include an evaluation step in our pipeline. Let's go to the website here really quick. And let's take a look to, actually, I'm going to start with the diagram that I have here. So we discussed the pre-processing step, which is this one here. We built that first. Then we talked about the training step or the training job, that's what SageMaker calls them, that uses the train and validation sets coming from the first step and it creates a model. And now we're going to be talking about an evaluation step. The goal of this evaluation step is to use the test set that we produced, that we created as part of the pre-processing step. It's going to use that test set to evaluate the model, to determine what is the accuracy of that model. That's what we want to do here. This evaluation step is going to be a processing job, just like the pre-processing step was, this split and transform step. SageMaker does not have a special evaluation step. So you have to simulate an evaluation step, or not simulate, but you have to run an evaluation step just using a processing job. And we know how to create that because we already did. So going back here to the website, we are going to be looking at session 7. And this is the diagram, the mini diagram that I drew here for you. So we're going to be getting the model from the training step, and we're going to be getting the test set from the pre-processing step. We're going to be using those two inputs into our evaluation step. And here we are going to compute the performance of that model. And we're going to take that performance and we're going to turn that into metrics, or those are going to be the metrics that we're going to use to register the model. And the goal here is when we put that model in the model registry, when we register this model, we want somewhere to say, hey, the accuracy of this model was 92% or 95%, whatever the number was. That is why we want to produce out of the evaluation step. That's what we want to get out of the evaluation step. All right, so let's go to the code. And the first thing that I'm going to do here is just create the script that is going to run as part of the processing job, okay? Remember, we're gonna be using just a processing job like we did before. We know how that works. We need to write a script. We need to define a processor, and we need to define the processing step and connect all of the inputs and outputs. That's what we need to do. So I'm gonna create a new folder. It's gonna call evaluation. I'm gonna make it part of my system path so I can load that script then and test it. And here is the script that's going to do the evaluation of the model. And this script is very simple and very short. Let's go line by line and figure this out. This is the entry point. And in the entry point, I'm calling the evaluate function, passing the model path. Where is the model going to be located? Because we want to evaluate that model. So we want to load that model in memory so we can actually evaluate it. What is the test path? What is the test data located? We need to load that data in memory so we can actually test our model. And what is the output path? Where are we going to save the outputs? Remember, the way the processing job works is we do whatever we have to do. And if we want to output anything, we save it in a folder, and later we can tell SageMaker where to get those outputs from. And SageMaker will automatically upload those outputs to S3. So these are the 3 paths that I need to run my function here. So let's go to the function. We already saw this as part of the training step. Here, I'm loading in memory my test data, my CSV file. I'm using pandas here. That's the first line. I'm loading that in an array, in a matrix, in a vector called xtest. And this xtest, then I remove a column. First, I'm going to select the final column. Remember, the final column is the target value or the answer, the proper answer. What is the species of the penguin? I'm going to put this in this Y test vector. And finally, I'm gonna drop it from the matrix, okay? So I'm gonna drop that final column. So I'm gonna start, let's say, with 7 columns, grab column number 7, that is the target, and then I'm gonna drop column number 7, so I'm gonna get 6 columns here and 1 more column here, which, by the way, I don't even know if it's 6 columns or 7 columns. I don't remember. But anyway, I have now my X test data and my Y test data, referencing the target value. Now we're gonna extract the model that comes in a model.tar.gc file. We're going to extract it from the path so we can actually load it in memory. Remember that one of the guarantees that SageMaker gives us is that the output of a training job, SageMaker will automatically turn or compress into a model.tar.gc file. So SageMaker is going to do that for us. Therefore, we know that if we use that output somewhere else, and we are going to use it here, what we are going to receive is that file called model.tar.gc. So that's what I'm doing here. I'm extracting that file using the tar file library. This is just a Python library that's gonna allow me to extract the file. After I open that file, I'm going to load it in memory using Keras. I'm using the load model function from Keras, and I'm passing the location of where the model is. And remember that we created that special 001 folder and we saved the model assets inside that folder. So I'm loading the model from that folder. Pretty simple stuff. After I have that model in memory, now I can run predictions with it. Now I can use it. We already did this also as part of the training step where we validated the model using the validation data. Now we're gonna do the same thing just using the testing data. So look how we call, or I call, model.predict, and I pass the entire test set. So I'm giving all of the rows, all of the samples from my test data to the model, and I'm asking the model to generate predictions with all of those samples. After I do that, I can turn all of those predictions, I can turn them into a vector containing only the top row. You know what? Let's try to do this. Just so, in case this is not clear for somebody, let's try to do this. I'm going to, let me look at my hard drive and see if I have a copy of that model, because look at this, I have it right here. So you know what I'm going to do? What do I do? Okay, I'm gonna do something like this. What I want to do is, instead of having that inside a script, I want to run it line by line, just so you see how that works. Hopefully this will give you a better idea of what's happening. So I'm gonna create a temporal directory. And the reason I create a temporal directory is just to add stuff inside the temporal directory without polluting my thing. Although I don't think that matters. That doesn't matter. I'm gonna do this then. So I need to import tar file, and hopefully this works, okay? Hopefully this works. The path is going to be code/serving, then model.tar.gc. So extract that. Where do I want to extract that? Extract that to directory. And then we need to import Keras. I just need to make sure that I get it from TensorFlow, because if not, I'm gonna get the wrong Keras. So import Keras and load that model. Load it from here, and hopefully this works, okay? Hopefully when I run this works. Ah, there we go. So we have a model now. Cool, that's awesome. So the next thing that I need to do is just load my data. So I need the test data. I don't have it here, so I'm gonna download it from the internet. I'm gonna just go to my S3 bucket. Let's open S3 here. And where do I go? I'm gonna go inside my, there we go. And I'm gonna go inside pre-processing, and I'm gonna grab the test data and I'm gonna download it. Cool, awesome. So when I do that, I'm gonna go to the download folder. I'm gonna grab this, go to Visual Studio and add it inside serving. I can delete it later. All right, so I need to load that data. So I'm gonna grab this code, which is the same code that we're using inside the script. And I need to load that data. What is the path? Well, it's gonna be code, serving, and then test, and I'm gonna do this. So I'm gonna start by doing this, okay? And after I read that, I'm gonna do this. Okay, so I'm reading now the test set in memory, and as you can see, when I print the shape of that test set, I get 51 columns, so that I have 51 samples, different penguins, sorry, rows, not columns, and 8 columns. So that's the number of columns that I have. Awesome. So that makes sense. Now I'm going to come and I'm going to grab the final column. That final column is the target column. So we want to get rid of it. First, I'm going to grab it. And remember that here by referencing -1, that it's telling NumPy that I want just the final column from that array. So this here, if I say .shape, that will tell me the shape of that, and it's just a vector. So see how it doesn't display the number of columns? That means it's just a vector. There are no columns here, it's just one array of values. Let's print this array here. You get here that array of values, see? So the first penguin is supposed to be class 0, the second penguin is supposed to be class 2, etc., etc. So that's good. Let me rerun this. Okay, what do we need to do next? Well, next we need to drop that final column from the data. So if I drop that final column from the data, I should get one fewer column. So if I print the shape, the number of columns should go down to 7. If I do that, now you can see that I just have 7 columns. Cool, awesome. So what's next is just to call predict. So I'm gonna do this. I'm gonna say model.predict, and I'm gonna pass the whole data set. And I'm gonna call these predictions. Let's run this. This is gonna take my model that I already have in memory, and it's gonna run predictions for every single one of my samples in that. So I should have 51 predictions back. So let's do this. Let's do predictions.shape and see what do I get. So I get the 51 predictions, but notice that I have 3 columns here. Why do I have 3 columns? Because every one of those predictions, let me just print the first prediction. Every one of those predictions consists of 3 values, and those are the softmax values coming out of the network. So in this particular case, I get 0.93, 0.002, 0.004. By the way, like we said yesterday, if we sum those values, they should sum up to 1, like you see right now. So summing up those 3 values, it should be 1. That's what the softmax activation function in the output layer of my network does. Cool, awesome. So I have this, but I don't want this. I don't want my predictions to be softmax values. I only care about what is the proper class. What is the index of the class that represents that species or that penguin. So if I print this out back then, you will see that, well, obviously, clearly, in this case, is class 0. How do we do that? Well, that's what this line is for. Remember that we used the argmax. So let's use the argmax here. Now, notice what's going to happen here because this is important. If I get these predictions, this prediction array, and I do an argmax to the whole matrix, I'm going to do X and I'm going to do X shape. Let's see what happens now. So, oops, that's not what I wanted. So if I do this, I just get this value here. What does that even mean? It's not giving me the index of every single class for each penguin because I'm applying an argmax without specifying which dimension I want to use. So I want to sort of like shrink this by columns, and the columns is the second dimension or the final dimension. So not argument, but axis. I'm gonna say just shrink this by the final dimension. And now I should get an array like this. Now I should have, if I say shape, I should have 51. I now have a vector with 51 values, and each value indicates what is the proper class of that sample. Again, if I'm printing X here, I get 0, 2, so the first penguin corresponds to class 0, then the second one to class 2, etc., etc. So what do I have to do now? Well, I need to compare these with the Y test. So this is X. I'm going to call it something different. I'm going to call it predictions. So I'm going to rename predictions. That's fine. So now I have predictions. And if I print Y test, this is what this looks like. And of course, this is just, I mean, it's the first one is just an array. The second one is a NumPy array. Let's do print here, just so maybe this looks different. No, it doesn't look different. I think there is a parameter for print, so they look different. So anyway, I need to compare these two to tell me what the accuracy is. So if they match, that's good. If they don't match, that's bad. How do I do that? Well, I can do that manually, or I can just import accuracy score. I don't remember how to import it. I think it's part of, here it is, sklearn metrics. So I'm going to import it here. And now I can say, okay, just give me the accuracy score between Between what? Well, between y test and predictions. And this should give me a value that looks pretty much like this. So it's 96% of my predictions were correct. So hopefully just going line by line here gave you a better idea of what I'm doing inside this script. So let's go back here. That got all the way to this line. I'm just compressing some of these lines into a single line. So here it gives me, I get my predictions. Here I compute the accuracy. Then I print the accuracy. So that 0.96, I'm gonna print it out. And then I'm going to create an evaluation report. And this evaluation report, you will see how this is useful later on. I can create this report, which is just a JSON file that I'm gonna save as an output. And notice the format, because the format is very important. So in this case, the format is, there's gonna be a top level element called metrics. The child is going to be the name of the metric, which is accuracy in this case. And then a child of accuracy is going to be value, which is going to contain the value. If I wanted to print a different metric, I could add, so let's say precision here, and I could just print precision. And then assuming that the precision was, I don't know, 0.80. If I computed that and it was 0.80, I could put it here. So this report is just a top level element called metrics, and then you're gonna display all of the metrics that you want to output out of this. What do I do with this report? I'm just gonna save it out in the output folder so I can capture it as an output when I define my processing job. So I'm creating the output folder if it doesn't exist already, and then I'm just writing that in a file that's called evaluation JSON. You can name this file however you want. I just named it like this, evaluation JSON, and I'm saving that report. I'm using JSON.dumps that turns that JSON object into a string, and then I'm saving that as just a regular file. So that is what my evaluation process does. Again, just to summarize, it loads the test data in memory, loads the model in memory, runs prediction using my model for all of the samples in the test data set. Then it generates this evaluation JSON object that contains the accuracy of my model, the accuracy that I computed, and then it saves that file. That is what the script does. I'm going to really quick remove all of the code that I used to just explore this. I don't need any of that anymore. And then we get here, and this cell here is just running unit tests for my, by the way, I can remove this file as well. Do I need anything else? No, everything else is fine. So this cell here contains some unit tests that I wrote, I think a couple unit tests. So I evaluate that it generates the evaluation report, and I evaluate that the evaluation report contains accuracy. If you think of other unit tests, please just add them here. It's just a good practice. So as you can see, I can run those tests and they both pass. So that's cool. So let's go and start working on the processor. Before I do that, I want to remind you that before this session, we saw how to call a tuning job. And the problem is that I wanted to show you here how you could use tuning or training to run this. The problem or the idea here is if you're running tuning, the way we get the output of the tuning job is different from the way we get the output of a training job. So I had to write a little bit of code to check whether we're using tuning or not. And if we are using tuning, then I need to access the output of the tuning job one way. But if we're not using tuning and we're just using training, then I access the output in a different way. That is what you are going to see right now in this step number 2, which is referencing the model assets. I'm creating a variable here that's called model assets. And I'm saying, okay, the model assets are going to be the S3 model artifacts coming from the training model step. So that's a property that SageMaker gives me access to that is going to contain the S3 location of that model.tar.gc. So I store that location right here. But if I'm using the tuning step, if that value is true, then model assets is going to look different. So it's going to come from the tune model step. I'm going to use this function that's called get top model S3 URI, and then that function is gonna get the top K equals 0. So the top, the best model, and it's gonna get it from this bucket here. I think SageMaker is overcomplicating themselves by doing this. They should have a similar property like this containing always the best model. I understand that through this function, you can also get the worst performing model or the second best model. They should keep the function, but they should have a property that's easier to access. But either way, with this cell here, I ensure I always get my best model, regardless of which step I'm using. If your pipeline always uses the same step, so if you only have a train step, you don't need all of this mambo jambo. If your pipeline only uses a tune step, so you can just access it like this. In my case, just because this is just to show you how it works, I have the property so I can check, or the flag so I can check which one and access the assets the proper way. Next step. Here is where the magic of the property files come through. So remember that our evaluation step returns that magic property file or report. I call it the evaluation JSON file. It turns out that SageMaker has a very nice way to map that type of output, that type of JSON output, to what they call a property file. And the reason this is important is because later on, we are going to access the values of a property file as part of a definition of the pipeline. And that's going to be really important, I think, for next session. Actually, in 2 sessions from now, that's going to become really, really important. But for now, let's do that mapping. And the way you do the mapping is very simple. As you can see here, I'm using a property file and I'm defining what that property file is going to look like. I'm going to call it evaluation report. The name, this is the name of my property file, evaluation report. The output name, this is the output from the processing job that we're going to define, is going to be evaluation. And you're going to see how we need to specify evaluation later on for this property file to match. And the path is just the name of the file that we saved. The path is evaluation JSON. So from a processing job, you could have multiple output files and you could define multiple property files. And through this definition, you define which property file maps to which object or to which file. So let's define now the processor. Session number 3, when we did split and transform, and we defined that processor job, remember that we used a job called the sklearn processor. Not a job, but a processor. So if I go to session 3 and we look at the code, what is our code? I should have gone directly to what I defined it. There we go. So you can see that I'm using the sklearn processor here. And the reason is because we are going to, or we require an image, a Docker image that supports scikit-learn. And this is an out-of-the-box class that's going to give us access to that. Well, it turns out that to run evaluation, we need something different. We do need scikit-learn, but we also need TensorFlow. So we need to use a processor class that comes out of the box with TensorFlow in it. Fortunately for us, SageMaker offers that. So if I go back here to session 7, let me open this so I can go directly. There is a class called the TensorFlow Processor class. And that TensorFlow Processor class is a Docker image behind the scenes, comes with a Docker image that already has TensorFlow in it, but it also has scikit-learn, which is great because it comes with both. So we don't need anything else. So I'm going to define this processor using that class. The base job name is going to be evaluation processor. So if you go to the list of processing jobs, you're going to see evaluation processor for that job. The image that we're going to use, the framework version, this is going to be 1.12. This image is it's not going to be anything if we're running this in SageMaker, because SageMaker will pick it automatically from this class. If we're running this locally, then SageMaker is just going to use the local one. The Python version is going to be 3.10. Again, all of those values are coming from the configuration. We already talked about that. The type of instance is going to be an MLM5 XLarge. The number of instances is just going to be 1. The role that we need, and the session is going to be a pipeline session. So this is the same definition that we did before for our processor. Again, compare this. Actually, let me open here the website because it's going to be easier to just look it up here. It's pretty much the same as this, right? just the base job name, the framework version, but except I'm just getting those values from the config, but same thing. Okay, now what's next is just to define the processing step. We already did this as well for session 3 for the split and transform processing step. It's the same structure. Obviously, the inputs and outputs are going to be different. So let's see. The code that we are going to run is coming from the folder and the script that we just created. What are the inputs? Okay, so if I go here, the inputs must be the test set that's coming from the pre-processing step and the model, which we have already in a variable called model assets. So let's see, what are my inputs? Well, first, I have a processing input coming from the pre-processing step, and that input is called test. Awesome. And the second input is just the source is the model assets, which is the variable that we just defined. So if we're running training, that input is coming from here. If we're running tuning, that input is coming from here. Pretty straightforward. Those are my two inputs. What are my outputs? Well, we have the evaluation report, remember? So my output is going to be, the name of the output is going to be evaluation, and the source, it's going to get that evaluation from this folder here. Remember, we did this. Now, there is only one thing that's new, and it's the definition of a property file. So this is the support that SageMaker provides for property files. I want a property file that's called evaluation report. And this evaluation report is the property file that we defined before right here. Notice how this output name, evaluation, has to match the name of the output here. So if I wanted to output something else, another JSON file with more information, I could have another here, point this to a different folder, let's say it's another, and then I could have another property file, and that property file here, this sometimes it just takes a second here for this computer to just process this big or large notebook. So this is another property file I could define just like this, but I will need to make sure the output name matches this output name here. All right, it's pretty straightforward. Let me just remove that. Cool, awesome. Obviously, I'm defining the same cache config that we've been using so far, but that is my processing step. What's left? Well, we just need to add that to our pipeline. So in our pipeline here, this is gonna be session 7 pipeline. We have the pre-processing step. We are gonna use either the tune model or the train model, depending on the value of this variable here. We are going to be using the evaluate model step. As a reminder, I'm adding them here in order, but remember that the order you add the steps in this array doesn't matter. SageMaker will determine the proper order based on dependencies. Other than that, this is pretty much done. Let's run it locally. This should run locally as long as I'm not using tuning. So I'm gonna go to the tuning step. I'm going to disable tuning. I'm gonna set it to false. Gonna go back to session 7. Actually, I'm gonna go back here and I'm gonna run everything. So I'm rerunning my notebook up to this point. I set tuning to false, so I don't run tuning because it doesn't run locally. And then I'm gonna run the session 7 locally because it should work because the evaluation step is just a processing job. So I'm gonna run this session here. Okay, session 7 pipeline is created. Let's go down to running the pipeline. Let's make this a little bit bigger. And now let's set this to session 7 and let's say it running. Okay, so now there should be 3 steps. The pre-processing step is gonna take my original data set, transform it, split it, training step, which is going to train a model, and then the evaluation step, which is going to evaluate that model. So it's still running here. It's beautiful to look at this working. All of this orchestration of steps, this excites me a lot. Okay, so you see, I just saw just the model training, all of the epochs going through. Cool. It's created something, boom, boom. Evaluate model succeeded. Look at this line right here. It says the test accuracy of our model was 98%. So all of the steps worked. So I'm not gonna run it here on camera in the cloud, but I'm gonna show you what that looked like because I already ran that. So you don't have to wait for me to do that here. So I'm gonna go to session number 7. And here is the execution of that pipeline. Look at this, the 3 steps. It's taking shape. Okay, so we're building up into something. We started with a single step. Now we have 3 steps. You get the pre-processed data here, you get the train step, and then you get the evaluate model. Something important that now that we have several steps, you start seeing. Look at the connections. The connections here represent dependencies. Notice that when I hover over pre-processed data, I don't know if you can see that. I'm going to try to make it a little bit bigger. When I hover over pre-processed data, it lights up 2 connections in blue. One connection that goes to train and another connection that goes to evaluate. That tells me that the train model depends on the pre-processing step, which makes sense. The train model uses the validation and the training data that comes. Those are outputs of the pre-processed data step. And the evaluate model also depends on the pre-processed step because it uses the test data. That is what that line gets created there. And then the other line is when I hover over the train model, well, the evaluate model also depends on the train model step because we're using the model that gets produced by the train model step. That is how you interpret this thing. This is taking shape. This is looking good. In the next session, we're going to talk about registering the model. We already evaluated that model. The next session, we're going to be adding that model to the model registry. So I'll see you then.